Okay, in this lesson we're working on solving a system of equation using elimination with either addition or subtraction. What we've been doing up to this point has been solving either graphically or with substitution. So this will allow us, using addition or subtraction, to substitute for or eliminate one of the variables. So in our equations here, and I'll go ahead and rewrite those on the right side of the page, or the left side, we have n plus d equals 24, and then we have n minus d equals 12. At this point, we have two equations, and if you notice, we have negative d and positive d. When we add these equations, this middle piece is going to end up turning to 0. So n plus n is 2n. D plus negative d is 0. So we've eliminated that. 12 plus 24, 24 plus 12 is 36. Next step is we need to solve for n. We can go ahead and divide by 2, and we end up with n equals 18. At this point, we take our 18 and we go plug it in for either the first or second equation. We can go ahead and select. I'll go ahead and choose the first equation. So we have 18 plus d equals 24. At this point we want d on its own, so we subtract 18 from both sides, and you end up with d equals 6. Okay, typically at this point we want to put the ordered pair in alphabetically. D comes before n, so our solution as an ordered pair would be, solution as an ordered pair would be 6, 18. Now taking a look at this system. As you look, go ahead and try and figure out which variable we want to eliminate. If you determine that it was the y's because they're opposite signs, you'd be correct. And again, I'm going to add the whole thing. So I want to add 3x plus 2x, that's 5x. I'll go ahead and add negative 5 plus positive 5y. That ends up being 0. And a lot of times we don't write the 0. And then we come and add negative 16 plus 31, and that will give us 15. So just rewriting in one color, we have 5x equals 15. In this case, we divide by 5, and you end up with x equal to 3. Again, I can take the 3 and put it in either into the first or the second equation. It does not matter. It's whichever one you'd think's easier to work with, or just the first one. So I'm going to go ahead and put it into the second equation. So we have 2 times 3, because we know x is now 3, plus 5y equals 31. And continuing and simplifying, we have 6 plus 5y equals 31. Can go ahead and subtract 6 from both sides, and you end up with 5y equals 25. Divide by 5, and y equals 5. And again, we need to give our final answer as an ordered pair. That's where these two lines would cross, and that would cross at the ordered pair 3, 5. Okay, go ahead and give this one a try on your own. Please note that the x and the y are not in the correct order, and you're going to have to move those. Okay, so you should have resumed the video by now. The first thing we're going to have to do is rewrite one of the equations so that they're in the same order. We can go ahead and go 4y plus 3x equals 22. This next one I'm going to go ahead and move the negative 4y to the front. The commutative property lets me do that. Plus 3x equals 14. We're going to add these equations. 4y plus negative 4y is 0. 3x plus 3x is 6x. 22 plus 14 is going to bring us to 36. We divide by 6, and you get the answer x is 6. And again, I can take that x equals 6 and put it into either one of the equations up here. We'll just go ahead and go 3 times 6 minus 4y equals 14. So we have 18 minus 4y equals 14. Subtract 18, subtract 18. And you end up with negative 4y is equal to negative 4. So y equals positive 1. Our ordered pair is 6, 1. Okay, in our next example, we need to solve using subtraction. If you take a look, if I were to try addition, 5s plus 9s would get me to 14. 2t plus 2t gets us to 4t. It doesn't eliminate. However, if we subtract, and I want to make sure I subtract every term, and a lot of times I just put a negative sign where those terms are, or the opposite sign. So 5s minus 9s gives me negative 4s. 2t minus 2t goes to 0. Okay, and we can go ahead and erase that now. And then 6 minus 22, I can think of it as 22 minus 6 if you prefer, and that's going to give you negative 16. Same sign add and keep, different sign subtract. You know the song by now. Divide by negative 4, divide by negative 4, and you end up with the final answer, s equals 4. You can go ahead and substitute that back into one of the original equations. I'm going to pick the first one, so 5 times 4 plus 2t equals 6. Okay, so then we continue on and we get 20 plus 2t equals 6. At this point, subtract 20, and you get 2t equals negative 14. Divide by 2, and I'm running out of space here a little bit. We'll just shrink it here. And divide by 2, t ends up equaling negative 7. Again, you might remember that the ordered pair is alphabetical, so s is before t. So 4, negative 7. And one more. Again, this one, things are lined up. So I want to go ahead and subtract all the way across. So I have a negative 8b, negative 7c, negative 7. So 8b minus 8b is 0. 3c minus 7c is negative 4c. 11 minus negative 7 is 4. So we divide by negative 4, and we're left with c equals negative 1. Go ahead and take that, plug it into either equation. I'm going to use the top one. 8b plus 3 times negative 1 equals 11. 8b minus 3 equals 11. We add 3, Okay, continuing on, we get 8b equals 14. We divide by 8, and we have b equals 14/8. I want to simplify the 14/8 to 7/4. So our ordered pair is 7/4 and negative 1. Okay, go ahead and give this one a shot. Hit pause, and then come back and see how you did. So start by subtracting, and when we do that, we want to change all the signs because we're subtracting every term. 12 minus 6 gives us 6n. Negative m minus negative m, or plus m, ends up being 0, so that's our elimination there. And we have negative 14 plus 8, leaving us negative 6. Divide by 6, and we're left with n equals negative 1. So we'll go ahead and put this back into the original equation. This time I'm going to go ahead and use the second one. And we have 6 times negative 1 minus m equals negative 8. 6 times negative 1 is negative 6 minus m equals negative 8. Go ahead, add 6 to both sides, and you end up with negative m equals negative 2, and m equals 2. At this point we want an ordered pair. M comes before n, so 2, negative 1 is our ordered pair. So that's solving systems of equations using elimination with addition and subtraction. Hopefully that helps.